We always wonder how exactly electrical generator has been invented. To be precise, at which year the electrical generator was being invented. In 1831, when Faraday invented the electromagnetic law. After that, in 1832, Hippolyte Pixii, a French scientist, invented the first electrical generator named as dynamo. Yes, it was named as dynamo. It was originally designed to be a DC generator, but Hippolyte accidentally invented an alternator. When he designed that particular generator, it gave him alternating current, but he was trying to generate a DC current. After that, so many different types of designs has been invented, and we got commutator, which is a device connected inside the electric generator, which ultimately converts AC to DC. And from that point till now, we have so many types of variants in case of electrical generators. Nowadays, we have totally shifted our electrical system to AC, but in 1800s, DC was very popular. In that case, DC generators were being used in different types of applications, like for lighting purpose, to charge the battery. Till now, we are using DC generator to charge our batteries for lighting purpose, for welding purpose. There are so many different types of uses of DC generator is still going on at this current particular time. In this experiment, we'll see exactly what are the parts are there inside the DC generators. People always wonder how exactly the DC generator looks like. What are the main parts of DC generators? We will cover all that part in this particular experiment. So let's see. DC generator consists of two main parts. One is armature, another one is the field. Armature keeps rotating inside the generator and the field is stationary. Sometimes people always say armature and field as their different name, which is stator and rotor. Stator is, like the name suggests, is stationary. That means field is actually the stator, and rotor, in case of a DC machine, the rotor is actually the armature. So two main parts of DC generator is armature and field. Inside armature, now we will see inside armature we have armature winding. We have armature core, in which the armature winding was being done. Then with the armature we have commutator, which is being attached to the same armature system. Then the commutator is actually connected to the brushes. It is not physically connected. There is a air gap between the commutator and the brush. We will discuss that in later part. We also has brush with the armature system. Now in case of your field, we have field winding, field core, and then field core is again divided into two parts, that is pole shoe. Field core has two different things, pole shoe and pole core. Inside field core we have two different things, pole core and pole shoe, and above the field core we always do the field winding. Basically these are the important parts of any DC generators are there that we will see in this experiment. We will see a practical motors also in which all these parts will be there. Apart from this, we also have apart from this main part, we also have certain auxiliary parts that we have to see is yoke. First one we will see is yoke. Second one we will see bearings. What is the need of bearing? Then sometime a DC generator also, a DC machine or generator also has fan inside this. Why it has a fan, we will discuss that in the later part. So in this experiment we will see all these parts connected inside the DC generator, in which we have two main components, that is armature and field. With that two main components we have yoke, fan and bearing as auxiliary component inside the DC generators. Now in case of field we can have two different types of field in case of DC generator. We can have a permanent magnet field or we can have an electromagnet field, PM and EM. That depends upon the size of the generator, that depends upon the company of manufacturer whether they will prefer a permanent magnet field and electromagnet field. Basically it is the magnetic field that generator gives in order to generate EMF inside the armature. Faraday's law electromagnetic states whenever you rotate a conductor inside a magnetic field, the conductor will experience an EMF. So you require a magnetic field inside the machine. This field will give you the magnetic field that can be of a permanent magnet or that can be electromagnet. That depends upon the size of the company. So now without wasting any time further, let's directly move to the practical and see what are the parts of DC generator are actually there in the system. Now as you can see, we are inside our machine lab, and this is the DC machine that we are going to discuss. Now in any DC machine, we have a specification plate in which we'll get all the data regarding that machine. For example, we'll have horsepower, we'll have how much RPM the motor or generator will be, armature volts, temperatures, and all different kinds of things. All of them are available in the specification plate of the DC machine. Now before moving forward, I will like to tell you two major important things. This is named as your driving end, where you connect the turbine or your load, and this is known as the non-driving end, where you will connect the tachometer to check or to measure the speed of that particular generator. Generally, in case of any DC machine, bearings are used in two different types of end also, in both non-driving end as well as driving end. Both the end will have bearing in order to reduce the friction. Now this is the part where the connections of DC generator is being made. As you can see, these connections are going out of that box and to the generator panel. Now we have to remove these two rings that you can see. Now we have to remove this screw, as you can see in your picture. This screw we have to remove by using different types of tools. Now you can use a normal flathead screwdriver in order to remove this, in order to unscrew this particular bolt by turning it clockwise. Now in this you can see we have already loosened these two rings. Now let's take it out from that motor, from the generator, and place it somewhere else. Now the second ring will be opened from this. As you can see, the second ring is little bit tighter, but we will open it anyhow. This is also will kept in another place so that we don't have to use this. It is very easy to open those two particular rings. Now when you open this, you can see this is the open view of any generator. As you can see, there is a fan inside the generator. This fan is usually used to maintain the perfect airflow inside the generator. The air will come from the outside of the generator and will go inside the generator in order to cool the windings. What happens is, generally because inside the generator the winding usually gets heated because of electromagnetic field stress. In order to reduce that particular heat, we usually use a fan which maintains the airflow inside the generator. Now if we rotate this, as you can see, now if I rotate this, you can see the fan is moving along with the armature is also moving with this particular shaft. The armature is totally connected with this shaft, so if I move it anti-clockwise also, it will move anti-clockwise also. Now at this end you can see, if you can guess, then you can guess what is this part is. We already discussed this part in your theory classes. This is your commutator. As you can see, the commutator has some segments, and if I rotate this by my hand, the whole armature will be rotating. Now if you look closer, you will see there are certain black particular things are there above the armature. If you see, now you can see in my fingers also there is a black thing. There is a black thing is attached to my finger also. You can guess what is that particular black thing. Now if you open this, there is a latch mechanism which is connected here. You can see there is a wire connecting to the brush. This is the brush that I will now open. This is the latch mechanism. You can see if I press this, then this will become the latch mechanism. I can easily open the latch and I can easily detach the brush. Now as you can see, this is the black type graphite. We already know that there is a graphite used inside the brush, so this whole black part is the graphite which is giving that black color substance. Now I have connected the brush back to the commutator. Now let's see how exactly the armature from inside looks like. Okay, now if you look closely, now I'll take my camera further inside the motor. If you look closely now, if I rotate this, you can see the whole armature is rotating. Now inside the armature, you can see this armature is rotating. Inside the armature, you can see the copper color part is your core, which is ultimately laminated, and inside the core the winding is done by the copper, insulated copper windings. Now you can see this part is the field. This is the pole shoe that we are discussing. The pole shoe is also laminated, and you can see the gap between the pole shoe and the armature is very less. This air gap is being maintained so that if the air gap is very less, the field pole will collide with the armature, and if it is very big, then the magnetic field will have more reluctance. If I rotate this, you can see that it is not colliding with each other. There is a certain amount of gap in between the pole shoe and the armature. Now if I rotate this shaft, if you want to see, now if I rotate this shaft, the whole armature and commutator part is rotating under the field pole. You can see if you rotate this, the brush is not actually connected to the armature. It is having a little bit amount of gap in between. Now you can see there are two poles are there inside this machine. One is on the other side, opposite sides. Now you can see this is the whole outer body of the DC generator, which is ultimately your yoke. This part is known as your yoke, which gives mechanical support to the generator. Now this is the connection part where we connect the armature and field winding. The armature 2 terminal and the field 2 terminal will be coming from inside the machine to this particular box. As you can see, there are total 6 terminals available in this DC machine. This is a compound wound machine, that is why it has 6 terminals, but generally we need 4 terminals, 2 for armature and 2 for field. This is for the armature part. It's going inside to the, it is connected inside to the generator also. Now you can see this wire is going towards the panel, but this is also another wire which is connected to the body of the generator, which is in green wire. That is, we usually use it for the earth system, or in order to, if you have any leakage, then the leakage will be transferred to the earth. Now this is the non-driving end of your DC generator. Now if you see closely, here you will also have bearing, which is totally greased in order to reduce the friction. Now you can see the total armature winding here. This is another fan end of, this is fan end of the armature winding. You can see the whole copper winding wounded inside this. This is how we wound according to the lap winding or wave winding. This is the other end, which is where the winding is connected to the commutator through the armature core. Now if you want to open this particular generator totally, then you have to open this part. You have to open this part. This will be opened like this, and also this part will be opened in the another direction. But the question arises, how we will open this part? You can see there is a bolt connected here and here also, then same like that in here also, and in the underside also. If you have to open all these bolt, then this part will come out of that particular generator, and same like we have to open this part also on the other opposite side. When you do this, this particular armature will come out of the generator with these two parts. Now once the armature is disconnected, you can open the field from this particular nuts. These are the two Allen keys. Now you can see here we have one set and another set is on the opposite side, because we have already seen that 2 field poles are used inside this machine. If you open this, both of the field will be opened, and you can use that particular field and you can wound that particular field